We are working through question 3. Let's begin by giving it a read. It says, the only possible outcomes when a coin is tossed are a head or a tail. When an unbiased coin is tossed, the probability of tossing a head is the same as the probability of tossing a tail. Joe has 3 coins in her pocket. 2 are unbiased and 1 is biased. When the biased coin is tossed, the probability of tossing a head is 1 in 3. Joe randomly selects a coin from her pocket and tosses it. A, find the probability that she tosses a head. This is worth 2 marks. So the first thing that we're going to do is make ourselves a tree diagram. So obviously the very first step is her reaching into her pocket and pulling out a coin. She has 2 unbiased coins and 1 biased coin. So she has a biased coin and an unbiased coin. The probability of her pulling out a biased coin, because there's 1, is going to be 1 in 3. And the probability of her getting an unbiased coin is going to be 2 in 3. The next step is going to be her tossing a head or a tail. So a head or a tail. If she's pulled out the biased coin, the probability of her getting a head is going to be 1 in 3 as specified by the question. And therefore the probability of her getting a tail is going to be 2 in 3. And if she's got the unbiased coin, obviously the probability is just going to be a half and a half. 50-50 odds of whether or not it's going to be a head or a tail. Okay, so now having figured that out, what we need to now figure out is find the probability that she tosses a head. So what I would do is I would say, well, the probability of her tossing a head would be, first she picks up a biased coin and then she tosses a head. So 1/3, 1/3. Or alternatively, she selects an unbiased coin and then she gets the head. So there are 2 ways of her getting a head. So we can now write that out. The probability of her tossing a head is going to be either the probability of a biased coin, the intersection of head, plus the probability of an unbiased coin, the intersection of head. The way that we're going to figure these out now is simply by going, well, this is going to be 1/3 times 1/3. 1/3 times 1/3. And then over here, it's going to be 2/3 times a half. 2/3 times a half. That means our answer here is going to be 1/9, and our answer over here is going to be 2/6. So we have 1/9, 2/6. The next thing that we would have to do is just simplify these down a bit, then add them together. 2/6 is simply going to be 1/3, 1/3. And then what I could do is simply multiply this by 3, by 3. That's going to be 1/9 plus 3/9. My answer is going to be 4/9. That is going to be my answer to part A. It's worth 2 marks, obviously a bit of working out there as well. Let's now look at the examination report and see how the state fared with this question. Where is it? There it is. Alright, so as you can see here, the same working has been used. This line right here is simply this line here, all the same working to get to that point right there. You can see that 68% of the state got the full 2 marks, so they've done reasonably well. Let's just look at the little comments that VCAA has provided us here. What do they say? They say, as this question was worth 2 marks, appropriate working was required to be shown. This could include computations or a probability tree diagram. That's what we did, with relevant branches clearly identified. In some instances, it was not clear which fractions were being manipulated or how they were manipulated. So just be very clear with your working out. Tree diagram is always helpful in these scenarios. Let's now move on to part B, in which we're being asked to find the probability that she selects an unbiased coin, given that she tossed a coin. She tossed a head. Let me read that again. Find the probability that she selected an unbiased coin, given that she tossed a head. So this is a conditional probability question, so we're going to write it like so. Unbiased is going to be B dashed, given that she has tossed a head. So we're going to now put head there. So that means what we're going to be figuring out is the probability of unbiased intersection with tossing a head over the probability of tossing a head. And we've actually done all that working out in part A. So the probability of getting an unbiased coin intersection with a head, if we come up here for a moment, unbiased coin intersection with a head, we know is going to be 1 over 3. So let's come down here and we can write 1 over 3 here. And the probability of getting a head, well, that's exactly what we figured out here, the probability of tossing a head. So that's 4 over 9. So it's going to be 1/3 divided by 4 over 9. Do not get tripped up here, please don't. If you are having trouble with it, you might just want to add the extra step of doing this. What we're doing here is we're going 1/3 divided by 4 over 9, which is just state change flip. So it's going to be 1 over 3 times 9 over 4. We would then do some cancelling. This 3 and this 9 is going to become 1 and 3. So that means my final answer is going to be 3 on 4. 3 on 4 is my final answer. So let's now highlight that. And now let's look at the examination report and see how the state fared with this question. So we'll come over here, there it is. Let's bring this over here. Okay, so 45% of the state got the full 1 mark for this question. As you can see here, this is what we have done. Most students correctly identified the conditional nature of this probability problem. It was noted that many students who did not simplify their answer to part A did not carry out the subsequent calculations successfully. So what that's really saying is that your ability of doing A correctly was very important for B. But overall, I think this is a very nice probability question, nothing out of the ordinary. Hopefully you found this okay, and I will see you in the next video.